The life that we see today on Earth began with water and transformed together with it for 3 million years before finding its way onto land. All living organisms require water to survive successfully. For instance, human beings can only live 1 week without water. The molecules that are in water are also present in chemical reactions that drive life's processes. It is the only common substance to exist in the natural environment in different states of matter and contains many different properties.
Molecule model. A water molecule is considered polar due to the opposite ends of its parts holding opposite charges. It has one oxygen atom, shown by the red piece, and two hydrogen atoms, shown by the white pieces, that create single polar covalent bonds. The oxygen atom has an electronegative charge, and the two hydrogen atoms are positively charged. The charged regions are attracted to oppositely charged parts of neighboring molecules. Water's hydrogen bonds allow properties such as cohesion, high heat of vaporization, and resistance to temperature change. They form, break, and reattach to accommodate these changes.
Density. Water has several unique properties, one of which is density. Density is the amount of substance in a given volume as in grams per milliliter or grams per cubic centimeter. Liquid water is 1 gram per milliliter. Normally, when a liquid is frozen into a solid form, the density of the liquid will be greater than the density of the liquid because the solid is more compact, allowing more substance in less space. However, when water is frozen solid, its density decreases. It prevents water from freezing from the bottom up. This is why ice floats in water and other beverages. Ice is made on the surface first, with the freeze making the water release heat to the water below making insulation.
The solvent of life. Sugar placed in a beaker of water will dissolve and become part of the solution. This liquid solution has water as the solvent and sugar as the solute. Other substances can also be used as solutes, although the idea that water is the universal solvent is incorrect. If this were true, then any substance that is in water or contains water would dissolve. Our cells are able to contain water without being dissolved, showing that water is a versatile solvent, but is not a universal one. Water is a versatile solvent due to its polarity as a molecule.
Cohesion. Water molecules stick together due to the ability of its hydrogen bonds to break and reattach to other bonds. When it's liquid, its bonds are fragile, thus being able to form, break, and reform at great speeds. Cohesion allows water to be transported to the vessels and all the way down to the roots and upwards towards the leaves.
Adhesion. Adhesion is the clinging of one substance to another. Adhesion of water to the walls of the plant vessels help counter the downward pull of gravity. For instance, capillary action in a glass tube is caused by the adhesive forces exerted by the internal surface of the glass exceeding the cohesive forces between the water molecules themselves.
Surface tension. Surface tension measures how difficult it is to stretch or break the surface of a liquid. Water has greatest tension. Hydrogen molecules are bonded to one another and to the water below. This creates an invisible film. An example would be when you overfill a glass of water and there is a film of water just above the rim.
Water temperature. There are some important temperatures that you should know. The first is that water boils at 100 degrees Celsius. The second is that the human body has an average temperature of 37 degrees Celsius. The third is that water at room temperature is 23 degrees Celsius. And the final is water freezes at 0 degrees Celsius.
High specific heat. Water's ability to regulate temperatures depends on its high specific heat, which is the amount of heat that must be absorbed or lost for 1 gram of that substance to change its temperature by 1 degree Celsius. The specific heat of water is 1 calorie per gram per degree Celsius. It will change its temperature less when it absorbs or loses an amount of heat. Heat must be absorbed in order to break hydrogen bonds and is released when hydrogen bonds form.
Evaporative cooling. The cooling of a surface occurs when the liquid evaporates. This is responsible for moderating Earth's climate, stabilizing temperatures in aquatic ecosystems, and preventing organisms from overheating.
Acid precipitation and pH. Pure water is supposed to have a pH of about 7. This makes water neutral. Unfortunately, pollution causes rain, fog, and snow to have a lower, more acidic pH, which can harm ecosystems. This happens when sulfur oxides and nitrogen oxides react with water in the atmosphere. We see this on the leaves, where acidic rain has burned through, creating holes.
Water continues to play an important role in the environment's fitness and in maintaining living systems in our environment. Its unique and flexible behavior is what makes it useful to Earth.